Dear viewers, welcome to the session. In this session, we are going to discuss the different operations on doubly linked list. In previous classes, we have completely discussed about the linked list. So, what is the drawback in that linked list? How it will be overcome? What is the additional types in the linked list? What are the operations? Those today we will discuss. We know about the singly linked list. The general structure for the singly linked list is, it is containing the address of the first element and then count. So, this is an example for what the singly linked list or list, generally what the list. What is the problem in this linked list is, we can traverse in only one direction. So, the traversal is possible in only one direction. Only one direction. It means that if we have reached some particular node, 50th node or 100th node, if you want to go back and search what are the elements are that before the 100th node or before the 50th node, here in this linked list it is not possible. We have to again start from the first node. If I want to reach the 25th node from the 50th node, means what? It is not possible. So, again I have to travel from the first node, first 1, 2, 3 like that. So, from the particular node I cannot travel back. Okay. So, I can reach the nodes which are presented after the particular node. If we are in 50th node, I can reach 75 node or 80th node like that, but I cannot go back. So, this is a small drawback is there in the singly linked list representation, but this will be what solved by introducing one more property for each node. It means that each node is now currently is having the data, actual data and the address of the next node. Instead, in each node we are going to store another information, that means that who is the previous node. So, the address of the previous node is also is going to be stored in that node information. So, the every node will know who is there in the front, who is there in the back. So, both the next and previous nodes informations plus the data informations are going to be stored in the node. So, if you are doing this modification on each node, that type of list is called as the doubly linked list. So, what we have discussed so far, what are all the operations we have discussed so far is a singly linked list. Okay. Then what modifications, if you are adding the one more property for in each node, which is called as the doubly linked list. Doubly linked list. So, this is called the singly linked list. So, we will see the structure of the doubly linked list. So, again the same, the list contains the two information, address of the first node and then what? The count, there is no change in that, and then what? 3, 3, 10 like that. But here the change is there in that each and every node. It means that 3/10th node, you see the structure of the 3/10th node, it is not having the 2 fields, it is having the 3 fields. One is the actual data, another one is that is a data field, and who is the next, and what? Who is the previous. Okay. Who is the previous. So, the address of the previous is going to be stored in this location, the address of the next is going to be stored in this location. for the first node there is no previous node. So, the previous field of the first node will be what? Null. The next node you say that is a 210. So, that what? The 210th node, it is the 210th node. This node also having what? The 3 fields, the 20 data and address of the next, address of the previous. So, what is the address of the previous node? This node address is what? 310. This node address is what? 210. So, by storing the next the 210 to here, it means that this is linked with this one. Similarly, the 210th node know who is the previous, it means that he is containing the information about the previous node. So, the 310 is contained in this field. It means that this is pointed in reverse direction also. Okay. So, the next is what? The next of the 210, next of the 210 is what? 110th node. So, draw that 110th node. This node also having the 3 fields 10, okay, and this is 110. So, he is having the information of the next node. So, that what? This arrow mark, and then he is having the information about the previous node, that is what? 210, then means what? It is this arrow mark. And address of the next of the last node, that is a 110th node is what? There is no more node. So, this will be what? Null. So, this is the minor difference between the singly linked list and what? The doubly linked list. So, this cases in each and every operations we need to change the algorithm. It means that in previous operations what we are updating only the 2 fields for each node, data field and the next field. But here we have to update the 3 fields for what? The each and every node, the previous, the next and then the data node. So, we need to modify that algorithm. So, we have to rewrite the algorithm specifically for the doubly linked list. Okay. So, now if we, what is the advantage of storing the previous node means from the 50th node, if you want to reach the 48th node, I can go back to 2 nodes. If you go back means you will reach the 48th node. So, instead in the singly linked list from the 50th node, if you want to reach the 48th node, I cannot go back, I have to travel from the first. So, I have to travel what? I have to cross the 47 nodes. So, it will take much time for the searching and some other operations. So, this is a doubly linked list. Some more variation is there in the linked list. Okay. This is some singly and doubly. So, one more variations is that, that is what? Circular linked list. Circular doubly linked list, that is what? CDLL. Okay. SLL, DLL and then what? CDLL, circular doubly linked list. What is the advantage in that circular doubly linked list means? Suppose even if you are using the doubly linked list, if you are having the 100 data, you have reached the 100th data, that is the last node you have reached, you are in last node. Now, you want to reach the third node. If you want to reach the third node means what? From the 100th node, okay, you can travel back. Okay, you can reach, or from the first node I can reach the third node. But from the 100th node, if I want to reach the third node means only we need to travel in what? Back side. But in the circular doubly linked list, it is giving the option that even if you reach the last node, okay, the last node is connected with the first node. In these 2 linked lists, SLL and DLL, the last node next field will be the null. But in the CDLL, the circular doubly linked list, the last node next field will be the first node. Similarly, what? The first node previous will be what? The last node. It means that the nodes are linked in circular way. Okay. So, we will see one example. The same circular doubly linked list is going to be changed as what? Circular doubly linked list, like that is what? 3 nodes are having 310 and then 210 and then 110, the data is 10, 20 and 30. We know these things, that is what? This node know that, that is 210, this node know who is the previous, that is 310, he know who is the next, that is 110, he know who is the previous, that is what 210. So, this is the first node. Actually what this contains, the first node first contains 310, okay, and then count is what 3. So, from the last node no, the last node next field is not a null actually. Now here it is pointing to the first node, that is what the 310 information is stored here. It means that okay. So, who's next? Similarly, this first node, the previous will be the last node 110. Okay, it means that like that. So, these two directions both will be there, that is what here first node is linked with the last node and last node linked with what the first node. So, that what the nodes are arranged in a circular way. So, this one more advantage is there in the circular doubly linked list, but the implementation is little bit difficult when compared to the singly linked list and doubly linked list, because during the insertion or deletion we have to make sure that whether all the fields are updated or not. Similarly, what in other two types we can easily identify who is the last node, that is the last node contains the null means, that is the next field contains the null means we can easily identify this is the last node. But here the circular linked list, it is difficult to find the last node because it is containing the address of the first node. So, we are not going to discuss algorithms for the CDLL. Okay. So, now we will discuss some algorithm for the doubly linked list, how to convert the singly linked list algorithm to what the doubly linked list algorithm. Also, we are not going to discuss all the operations in the doubly linked list. We will discuss the basic insertion and deletion operation for the doubly linked list. Now, we will discuss the doubly linked list operation. First, we will discuss the algorithm for inserting an element. Insert front. Insert front. Okay, here our input is what? The data to be inserted. Where data to be inserted. Okay, assume that the linked list is an empty one. The linked list is what? Empty one. F contains the null and then what? The count will be the 0. Okay. So, in the insert front, the insertion, the first step is what? We have to what? Create a new node. So, one is what? The n equal to what? Create a new node. New node. Okay. So, it means that it will create a new node of the doubly linked list, not the singly linked list node. So, it will create a new node. It means that if I want to insert, for example, this is the m dot, okay, insert front of 10, like that if you have called. Okay. So, what is the thing is, it will create a node like this. Okay. So, the new node named as the n, the address you say it is a 110. Okay. So, the value will be assigned. Next to what we have to initialize, this is the n, we have to initialize the 3 fields. We have to what? Initialize the 3 fields. The second step is what? The node is created successfully or not, that we need to check. That is what? If n equal to what? Null, it means that the memory is not created. So, then we have to return false. The operation is what? Failed. And then end if. Okay. The third step is what we have ensured that what the node is created. Now I have to check what I have to fill the three fields, that is n of next and n of previous and n of the data. The n of next will be the initialize with the null, and n of previous will be the null, and the data will be the incoming data, that is what data. So that what this will be filled with null, this will be filled with null, and the data field will be filled with 10. So now I have to link this with the what the existing list. So if the existing list is on empty, okay, no need to write the complex code. Just I have to make what the first should pointing to what the newly created node. That's all. No need to change any extra informations. Okay. So just you check and first the list is an empty. After linking, creating this link, just you can return what true. So that is the fourth step. That is what if these three steps is what common. Fourth step is what if the current first is equal to what null. It means that initially there is no node in that list. Then the newly created node is only what? Yeah, first node. So I have to update the first equal to the newly created node. Newly created node is what? The n. So that I have to update. We will use this syntax for the algorithm. Okay. So next is what we have stored this address. It means that the 110 is copied to what here. It means that this link is what created. No more link to be created for what if the list is an empty. So only we have to what increment the count. So count equal to what? Count plus 1 plus 1, and then just what return true. End if. So this is for what if the newly created node is going to be a first and last node. Okay. So this is the status if the list contains only one node. That node first field as well as the last field both will be what? The null. The next I wanted to insert, that is what m dot insert front of 20, like that I wanted to insert. So what is the existing one is what? F, and then it is containing the 110, and then C count is the 1. Now the list contains only one node 10, this is the 110, this and this will be what? Null. Okay. And this pointing to this node. Okay. At this situation, this algorithm is not completed. Okay. At this situation, if you are calling that insert front of 20, this up to the third step is a common. What is having what will be done is a new node will be created. You say the address is the 210. So this is the n. Okay. So then the 20 and this will be initialized with what? The null. Okay, the 20 and this will be what? Initialized with null. So now I have to what? Add this newly created node as a first node. Okay, you see the diagram. Okay, first analyze what links have to be created, then you can write the code. Here in the fourth step, if you are checking the first equal to null, first is not null. So we have to write some other code for linking this. See that what are the links to be created first? First one is what? This link have to be what? Joined here. That means that it needs to be what? Cut. Okay. The next what? This link have to be created. Okay. This link have to be created. It means that is need to be what? Cut. Is this enough to create only these two links? It is a doubly linked list. Doubly linked list means what? Every node will know the previous node address also. So, we have to what? Create this link also. That means that the current first node, we need to inform the newly created node is the previous node, because for the current first node the previous node field will be what? Null, but I have to what? Inform that also. So, what is the code I can write here for algorithm? I can write here fifth one. If it is not a null means what? I have to copy this into what? 210. First node equal to f equal to what? The newly created node. So, before assigning this, okay, before creating this, just you update these two links, okay, that is what? This 1 and 2 you have to create. It means that the existing 1/10 previous field is equal to what? I have to assign what? 210. Similarly, 2/10, okay, next field is equal to what? The 110. Like that I have to assign. This is the link first to these two links creation. So, 1/10 previous 110 means how can we get this information 110? We just told 110 is nothing but what? The existing first node. So, I have to write what? The existing first node first of the previous, okay, is equal to what? The 210. 210 is nothing but what? The newly created node. So, what is created is that this link is created as a first one. So, this field is updated with what? 210. Okay. This field is updated with what? 210. So, that what? This link is created. Next 2/10 next have to be filled with what? Current, that is a 110. It means that n of the next have to be what? Filled with 110. 110 is nothing but what? The current first node. So, what? First. So, that what? This link will be what? Created now. So, this field will be updated with what? 110. Now, still the first pointing to the 110, but newly created node only what? The first node after calling that function. So, I have to update the first field also. So, the first is equal to what? First is equal to the newly created node. Then I have to what? Increment the count. Count equal to what? Count plus 1 and then return true. So, this is the fifth step, okay, if it is not a first node, okay, that is if the list is not an empty, we have to what? Execute this one, then end insert front. Okay. So, this will be updated with what? 210. Okay. So, 210 and this field is pointing to what? 110 and this will get updated, this field will get what? Updated. Okay. This is what insert front is a very simple algorithm. Next we will discuss algorithm insert end. Inserting a new element at the end of the list. Okay. So, what information we need means what? Val and then data. Okay. So, here as usual what? The first 3 steps are the common, that is create a new node. Okay. Okay. And the second step is also what? The common. If n equal to what? Null, then return false. We cannot what? Insert end if. And third step is also what? Common. You fill the fields, that is what? N of data field and n of what? Next field and n of the previous field is equal to what? Data and this equal to null and this equal to what? Null. Also what? If the fourth step also we can make it common. It means that what? If the existing first is equal to what? Null, no need to write any complex code. Okay, the first equal to null means what? We are going to, even if whether you are going to insert the last or first, Okay, the first is the null means what? The newly created node is the first and last node. So what you can just do what? Update the first field first equal to what? This n newly created node, then count plus plus the symbol will change to the arrow mark, and count equal to what? Count plus what? 1, and then return true. So the first 4 step is common with the insert front. Okay. The next what we need to what? Write the code for if it is not a first node. Okay. You see that one example for that, f contains 310 and count is the 3. Now the first node 30, okay, and the second node 20, and the third node 10. Okay, he is containing this information 310, 210 and 110, and he contain the 210. This field is the 110 and this field is the 210, and this field containing the previous address 310, and this is a null and this is a null. Assume this list. Okay. Now I wanted to insert what? M dot insert end of some 5. The element 5 needs to be inserted at last. Okay. So as per our code 4 step, newly created a node will be created in somewhere. Okay, and this field will be initialized with null and what? This one. So that what you say, this address is the 410 and this is the n. So newly created node is what? The 410th node. The data field is a field, the next and previous field will be the null. So now the thing is what? I have to search who is the last node. After identifying the last node, I have to write the code for linking the new node with the last node. Okay. So what is the code I can try to search? Fifth step, searching a last node. Okay. So searching a last node. This is similar to what? The singly linked list. Introduce a variable t, you make the t pointing to the first node, okay, and move the t towards the last node. The last node can be identified by what? Checking the next field, whose next equal to null, then we can say that is a last node. So t equal to what? The first, current first, then increment the t while t of what? Next not equal to null, and do the following: increment the t, it means the what? T equal to what? T of next, and then end while. So here it will be checked 210, it is not a last node, it will be moved here. Then what? 110, it will not be moved. Then this next field is a null, so it will get terminated. T of next equal to what? Null, so it will get terminated. So we know that address t and then what? N. So I have to create the link between the t and what? The n. I have to create a link between the t and n. So only 2 links have to be created, this and what? This, then you can return true. So what is the thing? T of next have to be what? Updated, and then n of what? Previous have to be updated. Okay. T of next equal to what? N, and n of previous equal to what? And t, and then count equal to what? Count plus 1, and then return true. Okay, and end, insert end. Okay, so that what? This link will be created, 410 is copied to here, and then what? The 110 is copied to here. So that what? The long, and then count will be updated with what 4 and it will return. So, this is the code for pseudo code for what inserting a node at the end of the list. Okay, the first is the null, means first we need to check the first is the null, then just you join the new node as your first node, then you return true. Otherwise, you have to search for a last node. Okay, so searching have to be done by introducing a variable t and moving the t towards the last node. Once the t reached the last node, I have to write the code for what linking t and what n. So here also we can identify the last node by checking the next field. So t of next field equal to null means we can identify it is a last node. Similarly, we will discuss one more operation, that is deleting an element. Algorithm and delete. Delete end and front. Okay. Now we will discuss delete by value. So value is data. So here that algorithm what we are going to discuss is not the delete end and delete front, that you try yourself. Now we will discuss, if you are passing one data, the data have to be searched from the linked list. Once that is found, we have to what write the code for deleting the element. Okay, search and delete. So delete by the value. Okay, so the input is the data. Okay. So here for the deletion, the first step is what we need to check the deletion is possible or not. Okay. So here I can check if the first is pointing to the null, first equal to what null, no need of what searching and deleting, just I can what simply what return false. Okay, and end if. Okay. Otherwise, the data have to be what searched from the list and then it needs to be what deleted. Okay. So this I will explain with one example. You say same example 310, so that it will be easy to remember. 30 and 20 and 10. Okay, 310, 210 and 110. Okay, and then this containing null, and this is the next and this is the previous, that is for 210, and then what this contain 310, and here 110, and this contains a 210. Okay, and this is the null. Okay, so suppose if we are calling that m dot delete of 20, like that if you are calling. So what I have to do? I have to look for the 20 where it is present. Once if it is found, whether that node is present at the first, or if that node is present at the last, or if the node is present at the middle. So there are three cases we have to what check once if you are finding that. And one advantage in the doubly linked list is what? In singly linked list, if I want to delete a particular node, we need to track the previous node, parent node of the node to be deleted. So we have to use two variables p and t. Whenever we are moving the t, the p also will get moved. So once if we are got the node to be deleted as the t, the p containing the parent, that is address of the parent of the t. So but here it is need not to be maintained. So once if you are identifying the node as a t, he contains the information about the both what the previous and then what the next. So easily we can change the link and then what we can delete the element. So only what we need to check what the t is present at the first or the t is present at the intermediate at last. Okay, like that only we need to check. So here you need to do the search first. So, I need to introduce a variable t here, and t equal to what? The first node, and we need to check the t needs to be moved until what? The end, okay, till the null. So, I have to check all the nodes. Once if you gone through all the nodes, okay, if that suppose the data is not found, that is a t reached the null by the time, okay. Suppose for example, if the data is the 5, you will check the 30 and 20 and then 10, then the t will reach the null. By the time it will get terminated. So, by the time I can say the data is not found. So, all the nodes needs to be checked. So, the t needs to be moved from the first node to what? The last node. So, t is not equal to what? Null. Do the following, okay. So, here at the end of the loop, okay, this here I have to take the action in between. If the data is found in between what? If the t of data, the t of data is matches with our data, it means that I have to write the code for deleting that element, okay. So, if the t of data is matches with our data, input data, we need to write the code for deleting the element. Here there are 3 cases. One is whether the t is pointing to the first node or the last node or the intermediate node. So, 3 cases we have to write, and then what? End if okay, then t needs to be what? Moved to the next, t equal to what? T of next, and then end while. When the loop will get terminated means that once the t reaches the null, it means that by default the element is not found. If the element is found means here itself what? It will be true, here itself we will take some action, it will be returned. So, at the end of the while loop, it means that the element is not found, so we cannot delete the data. So, return what? False, and then end delete. Here only we have to write the code for deleting that element, okay. So, what I told is what? If once if you got the t, it is a first node. How can we check if it is a first node? If t of what? Previous is equal to what? Null, okay, then what is the code I have to write, okay, for deleting the first node? Else if the t of what? The next equal to what? Null, it means that this is the last node, okay. If the t of next is, else if means what? If the previous is not a null, then you check whether the next is a null. If the next is a null means what? It is a last node. So, what is the procedure to delete the last node? And third case is what? If else. Else means what? By default what? The third case, it is an intermediate node, okay. So, this case 1, case 2, and then what? Case 3 we have to what? Differentiate. So, one is what? The node to be deleted at the first node. Second one is what? The node to be deleted is the last node, and third case is what? Intermediate node, okay. See here our case is what? 20 is existing here, okay. Just to see that if t of data, t is not equal to null, t of data is 30. So, what? This condition false, then what? At the end of this end if, okay, here the t will move to the next, this time what? T of data equal to what? Data. So, our element is found. So, now it will be checked whether t is a first or last or intermediate. Here this case previous not equal to null, and what? The next is also what? Not equal to null, by default the third case. The third case is what? It is an intermediate node. Now, see the diagram to create the link and delete the node, okay. So, what the link have to be created means between the 310 and what? The 110, and then what? Between the 110 and then what? 210, this link have to be created. then the T have to be what? Freed. Okay. So, 310 of what? The next have to be what? Filled with 110. Okay. The next what? 110 of previous have to be what? Filled with what? The 310. Okay. The problem is we know only the 210. T is nothing but what? The 210. How do we get the 310? How do we get the 110? So, 310 and 110 information are there in the T itself. So, the 310 how can we get means what? T of previous. So, what I have to write? T of previous of this will give the 310 whose next is equal to what? 110. Are you clear? So, we need to get the 310 information. The 310 information is there in the T. Okay. So, this field previous field. So, the T of previous of the next which is equal to what? 110. The 110 how can we get means what? The which is also there in the T, that is what? T of next. So, T of what? Next. Correct. So, this will be changed to what? This will be changed to the 110. It means that this link is created. Okay. The next I have to create this link, that is a 110 of previous. 110 how can we get from the T? T containing that information, that is what? T of next. So, T of next of what? The previous is equal to what? T of next of previous is equal to what? The 310. 310 information we can get it from the T, that is what? T of previous. Okay. So, we have created this two link. Now, this memory is not needed. So, we can what? Delete that T. So, just to what? Delete of the T. Then we have to reduce this size is equal to what? 2. So, count equal to what? Count minus 1. Count minus 1. So, then I have to what? Return false, sorry, true. We have what? Deleted the data successfully. So, this is the third case, that is what? If the node to be deleted at presented at what? The middle. Okay. And the next case is what? If the node to be deleted as a first node or the node to be deleted as a last node. Okay. So, how to solve it? So, see the same thing, one example, F and 210 and then count equal to what? 2. Now, this contains that information 210 and this contains the information 110. Okay. So, this is the null and this is 110 and this is what? 210 and this is a null and 20 and then what? 10 data. Okay. Now, I wanted to delete the same 20. Now, the 20 is presented at the front. Okay. So, we will start with what? Searching the 20. So, T pointing to what? The first node, that is what? This node. In the beginning itself, the first iteration itself was the T of data matches with our data. Now, it will be checked T of previous equal to null or not. Now, you check the T of previous is equal to what? Null. So, now we got the node to be deleted we identified and that node is the first node. Okay. If that node to be deleted is the first node, you have to write a different code. We cannot create this link because there is no previous node. So, we have to write the different code. See the diagram, what code we have to write? Only what? I need to create this link. It means what? The next of what? The T will become the first node. And then the 1/10 that is the next field is that the 1/10 node have to be what? Changed to what? Null. It means that this link have to be what? Cut, because this memory is going to be what? Freed. So, deleted. So, that I have to what? Make this previous, that is what? The 1/10 previous needs to be what? Updated with what? The null. So, what modification I have to done is the 1/10 previous is equal to what? Null, and then what? The F equal to first equal to what? Instead of that 110 210 it needs to be updated with what? 110. So 110 like that. So how can we get this 110 information from the T means what? The T of the next field containing the 110 information. Okay. So that I have to write here. So the T of next field of what the previous is equal to what null, okay, and then previous equal to null, then I have to change first equal to what, first equal to the T of next, the first equal to what T of next, that is this link will be created, then what, first equal to T of next, then I have to what, delete that memory, delete of the T, and then count equal to what, count -1, and then return true, okay, return true. And then the third case is what, the node to be deleted at the presented at what, the last. So here another situation, that is what, F and 210, and then C count is the 2, okay. So now as per 20 and 110, now this contains the 10, 210, 110, and then what, 210, okay. So now if I want to delete m dot delete of 10, okay. So as per our algorithm, the T will be initialized here, okay. T data is 20, here our data is a 10, it will get incremented, okay. Now the T data is a 10 matches, so that by that time the T of previous is not equal to null, but the T of next equal to what, null. So it is identified that the T is a last node. So if I want to delete this last node, okay, what I have to write means, okay, the 110 of 210 of what, the next equal to what, the 210 of next have to be updated with what, null, okay. 210 of next have to be updated with null, then this node can be what, deleted. So only what I have to write, what, T of previous, T of what, previous is having the 210, whose next field equal to, next field equal to what, null, okay. Then delete of what, T, then what, count equal to count -1, and then return true, okay, return true. So this is the three cases we have discussed, but one more case is that, that means that is if the F contains the 210, okay, and C is having only one node, it means that here we have the data 20, okay, and this field will be the null. So here see that cases here, I want to delete m dot delete of what, 20. It means that as per our code, okay, the T of data equal to what, our data. The first iteration itself it will be true. Now the T of previous equal to null. It means that it will be identified that what, the first node, because T of previous is equal to what, null. So it will be identified that what, the node to be deleted is a first node. So if you are executing this code, it will not work for this case, because the T of next of previous equal to null, like that you have assigned. So T of previous is actually what, T of next of previous. Here what is the case? T of the next is equal to what, actually null. So the T of the next of the previous, the next is the null of previous is not possible. So, in this case here this code will not work. So, it will return the error. So, T of next of previous is not equal to null, because the node to be deleted is the first and last. Okay. So, it should come in the first case as well as what the second case. So, how can we solve it means, so before assigning, in this case what is the case, the previous is equal to null, but there is no further nodes. So, what I have to do means that the first have to be changed to what, null, that is all. The first needs to be what, changed to null, then I have to what, delete that element. So, what I can do here is, only this case I can change as if the T of next is not equal to null. Okay. If the T of next is not equal to null, then the T of next of what, the previous is equal to what, null. Okay. If the T of next is a null, else, okay, I can add that what, the first equal to that, that means what, this code, the first equal to T of next, we can continue from here. The first equal to T of next means what, the T of next is the null. So, by default it will be assigned as what, the null. So, I have to add here end if. It means that only this case, this statement is depends on the condition, that is what, T of the next is not equal to null, then the T of next of previous equal to what, null, otherwise no need to assign, only first equal to what, the null, and delete the T and count to minus minus. So, we have verified all the different situation of the deleting an element. Okay. So, we will summarize the today's session. We have today we have discussed the doubly linked list, okay, the drawback in the singly linked list and the doubly linked list, in which each and every node will have the three kinds of the information, the data field and the address of the next and address of the previous node. So, that what we need to change in that algorithm also. So, we have discussed three algorithms: inserting an element at the front, inserting an element at the end, and deleting a node. So, deleting a node by searching an element. So, these three algorithms we have discussed for the doubly linked list. Okay. Some more operations we will discuss related to the doubly linked list in the next session. Thank you.